Well, this morning I want to make a few introductory remarks before we get into China's internal investment. The first is that the new 13th edition of the ABCs of Communism, which is Bolshevism 2017, is now available at Kindle books and Amazon. And I would suggest that those of you who are taking this course seriously will want to get that, because it's the first complete rewrite I've done since we started 13 years ago. And it has 2 volumes this time, not just one. That was a suggestion of one of you viewers and readers last time, which I took to heart, and accordingly we now have 2 volumes, both of which are rather large. The second is History of Communism in Latin America, from primitive communism to the struggle for modern communism today, and as far as I know, it's the only treatment of that kind in existence, so it should be helpful to many of you for a variety of reasons. At any rate, let's go on to several facts that I want to point out with regard to China's internal investment. And the first is that China has always been at the center of global technological innovation and advancement of its associated classes. And this statement contrasts with the completely illusional Eurocentric view that technological invention is Western. For example, historical firsts for China include paper making and printing, the compass, and gunpowder. And I made the point in the chapter on capitalism in your textbook that the steam engine was a Chinese invention, as was the blast furnace many centuries before it came to Europe. The second point is that China is the archetype pure example of socio-cultural evolution, from primitive communism through the transitional stages to the servitude epoch, and now from that epoch through the socialist transitional stages to the struggle for modern communism. And you will recall that I hope you will anyway, that challenge is the third point that we have tried to make in this book. The third point for the further development of the preceding point, which is that in China, where the development of challenge required the professional specialization of labor and its concomitant, the incipient social stratification in the form of social ranks, occurs in its purest form. Because the research into class and state formation occurs in the happenstance of European and North American scholarship, what we have seen traditionally is the erroneous idea that civilization emerges first in Mesoamerica, the Central Andes, Egypt, and Mesopotamia. In Mesoamerica, it was the exigencies of trade in obsidian, salt, and hard stone from central Mexico to the Yucatan that performed that function. And in Peru, it was high-altitude irrigation and intermontane road construction that created the challenge leading to ranking. In Mesopotamia and Egypt, it was the hot and arid climates of the deserts of Arabia and Southwest Asia. We discussed these challenges and the results in detail in your textbook. However, in China, the sheer agricultural plenty of the vast region of central China, by which I mean that region that has its center from the Wangho to the Yellow Rivers, that allowed a massive population explosion, and the irreversible release of surplus social product inherent in the agricultural revolution generated the population explosion that created the challenge requiring the professional specialization of labor with differential reward for every person, thus taking people from the stage of tribal agriculture to the stage of slavery via the chiefdom transitional stages. In the previous lecture, which was 4 months ago, when I had to stop in order to do this rewrite of the entire book, I discussed the problem of overproduction in Marxist terms. The emphasis was on the export of surplus value to other parts of the world through the Belt and Road programs of the Communist Party of China. Now, this is a policy that is in addition to the core program of internal surplus value investment, which is where we shall move next now in our discussion, having made the point that innovation in technology is nothing new in China. China has always been the focus of such advancement in global historical socio-cultural evolution. It is only the recent fact of European and North American temporary leadership in the emergence of capitalism and the bourgeois classes which has masked this fact for so long, and I discussed before why Europe temporarily moved ahead of China in the chapter on the origins of capitalism. The core of surplus value destination for China is, however, internal, and that itself has to be constantly reinvented. Now, these are fundamental economic concepts that we pursued in the chapters on slavery, feudalism, and capitalism. These concepts are no less true in the socialist transitional stages leading to the communist stage as the beginning of the era of freedom. In short, innovation, meaning invention in technology and the application of technological advance in the mode of production, is the main task of communists of China. Accordingly, the State Council on Monday last announced two scientists, physicist Zhao Zhongzhen and pharmacologist Tu Youyou, had won the country's top science award for their outstanding contributions to scientific and technological innovation. And at the recent Science and Technology Award Conference, Premier Li Keqiang outlined the party's program as follows. And I'm going to read some sections of that because this is an extremely important document. Today we are gathered for the important occasion of the National Science and Technology Award Conference to honor professionals in science and technology who have made outstanding contributions to advances in their own fields and to the modernization of China overall. Just now, General Secretary Xi Jinping and other party and state leaders presented the highest national award of science and technology to academician Zhou Zhongxin and researcher Tu Youyou, and conferred other awards to their winners. Here, on behalf of the CPC Central Committee and the State Council, I wish to extend warm congratulations to all the award winners and convey cordial greetings and high regard to all the science and technology professionals in China. My deep appreciation also goes to foreign experts who have participated in and supported the development of science and technology in China. Last year, thanks to the strong leadership of the CPC Central Committee, with Comrade Xi Jinping as the core, China made notable strides in economic and social development, despite complex and grim internal and external environments. Major milestones were recorded in fields of science and technology, and numerous outcomes in innovation were achieved. The CPC Central Committee and State Council convened the National Science, Technology, and Innovation Conference, issuing a clarion call to build China into a science and technology giant. Vigorous efforts were made to implement the innovation-driven development strategy, such as the promulgation of the outline of the National Strategy on Innovation-Driven Development and the launch of programs for major science, technology, and innovation projects toward 2030. Reform of science and technology institutions and innovation in management were accelerated, and a distribution policy that puts premium on the value of knowledge was introduced, which effectively incentivized science researchers. Science breakthroughs were made in science and technology, many of which reached an internationally advanced level. And let me list a few. And he mentions the Shenzhou 11 manned spacecraft successfully docking with the Tiangong-2 Space Lab, and astronauts managed in a medium-term stay in space. Just as a matter of interest, China had to build their own space station because NASA refuses to allow the Chinese to land on their space station. The world's first quantum science experimental satellite, MOSI, was launched. The supercomputer Sunway Taihu Light, powered by a homemade chip, held the current world record. Outcomes of science, technology, and innovation are now commercialized at a faster pace, and the initiative of mass entrepreneurship and innovation gained a strong momentum. Innovation is the primary driving force, is exerting a notably positive impact on growth. Innovated in China, won international recognition, made the Chinese people proud, and unleashed enormous energy that invigorated the whole nation. A new round of technological revolution and industrial transformation is in the making, further sharpening international competition to stay ahead of the curve. China has entered a new phase of economic development featuring deep structural adjustment and the renewal of driving forces. Only through innovation can China sustain the strong momentum of development. More than ever, the powerful force of science, technology, and innovation is called for, and we must conscientiously study and act on the thinking laid out in the important speeches of General Secretary Xi Jinping, put innovation at the center of development, and follow the new vision on development. Specifically, we will focus on supply-side structural reform, deepen the implementation of innovation-driven development, and transform traditional drivers of growth while fostering new ones, with a view to maintaining a medium-high rate of growth and reaching a medium-high level of development. We will build up the capability of scientific and technological innovation across the board to lay a solid foundation for our country's core competitiveness. We should closely follow frontier trends in science and technology and make early and visionary planning for research and application in focal areas in light of the needs of our economy and society. National scientific and technological programs and projects and key infrastructure must be implemented and built to support innovations in science and technology. We must strengthen basic research and original innovation, give full play to the central role of scientific research institutes and universities, and develop long-term and stable supporting mechanisms for researchers engaged in these areas to delve deeply into their areas of endeavor. It is by no means easy for them to work quietly and thanklessly for long years, yet their effort will be adequately rewarded once the breakthrough comes. To encourage social input in innovation, a mechanism needs to be put in place to encourage companies to play a leading role based on market rules, and we should also encourage greater openness in scientific and technological innovation by enhancing international cooperation and leveraging the Internet and other new platforms and models to develop synergy among industries, universities, and research institutes. We should pool and upgrade factors of innovation and raise the efficiency of commercialization of innovation and research outcomes. We will deepen institutional reform for scientific and technological development and fully motivate professionals working in these fields. Talents hold the key to innovation. We must give full respect to scientists, engineers, and technicians, guarantee their rights and interests, and tap their potential to the full. The government must further streamline science and technology administration and delegate powers and provide better services. A checklist-based management approach should be taken to strengthen and simplify rules, whereby greater autonomy will be given to institutes and universities in their research activities, and greater say to leading professionals of innovation in allocating research personnel, funding, and resources. The government will vigorously implement policies regarding the usage of research outcomes, distribution of research yields, equity incentives, mobility of talents and permissions for researchers to take part-time roles and be remunerated for that. All these will help to duly recognize and reward innovators, thus providing long-term motivation for scientific and technological research and innovation. We will encourage mass entrepreneurship and bring out the society's potential for innovation. Our people are makers of history and also the fundamental driving force for innovation. We have over 170 million people with higher education or professional skills who are endowed with great potential for innovation and form the biggest treasure house for our country's development. We must enable all talents to apply their potential, pool their talents into strength, and raise the efficiency of the innovation. We should help both professionals to make new innovations and the common people to explore their creativity. We should both support domestically educated talents to scale the heights of their professions and encourage overseas talents and foreign professionals to pursue startups and innovation in China. The Chinese government welcomes talents with an open mind and open arms. We will provide greater space and broader platforms for all innovators to fulfill their potential. We will comprehensively improve our supply capacity for innovation and facilitate the application and integration of scientific achievements into all sectors and fields to speed up the shift to new growth drivers, which are derived both from the emerging industries and the upgrading of traditional sectors. Driven by scientific innovations, the emerging industries in China are thriving, spearheaded by new forms of business like the digital economy, sharing economy, and platform economy. Proper regulation must be exercised to ensure healthy development of these new sectors, and meanwhile the new technologies, new forms of business, and new models must be integrated into the first, second, and tertiary industries at a faster pace to infuse traditional industries with new vitality. We need to introduce extensive policy incentives to encourage innovation. Such measures are additional deduction of R&D spending in taxable income, and accelerated depreciation of fixed assets should be better implemented. Greater support should be given to companies in setting up collaborative innovation platforms with universities, research institutes, and makers. We should popularize the innovation approach based on core group innovation enabled by wider circles of collaboration. We need to strive for parallel progress of innovation at the source, commercialization of R&D results and market development, and aim to develop more new high-quality products excuse me, that boost the competitiveness of our industries, meet the diverse consumer demand, and help tackle thorny issues such as in medical care and environmental protection, with a view to raising the quality of Chinese manufacturing and influence of products created in China. We need to enhance protection of intellectual property rights and foster an innovation-friendly environment. Protecting intellectual property is protecting and incentivizing innovation. We will pilot integrated management of IPR, establish a system for IPR creation, protection, and application, and crack down on IPR infringement and counterfeiting to safeguard the legal rights and interests of innovators and turn more intellectual property into real productivity. We need to foster a social environment that embraces innovation and excellence and respects hard work, knowledge, talent, and creativity. We should enable each and every one to innovate wherever possible and celebrate the spirit of innovation together with entrepreneurship and workmanship to generate strong impetus for innovative development. As science and technology change the world, innovation shapes the future. Let us rally more closely around the CPC Central Committee with Comrade Xi Jinping as the core, cherish the honor the country has conferred, conscientiously fulfill our mission, and strive for greater achievements. Attaining better and faster progress of our scientific and technological endeavors would be the best way for you to greet the opening of the 19th CPC National Congress. By joining hands, we will make fresh and greater contribution to the realization of the two centenary goals and the Chinese dream of the great national renewal, and to the building of a prosperous, strong, democratic, culturally advanced, harmonious, and modern socialist country. And that was the end of his talk. Now, I noticed that the British Broadcasting Corporation had a short article. What I thought it was interesting because of what they highlighted. China has made many breakthroughs in science and technology, it said, including high-temperature superconductivity, quantum theory, and stem cell research. Other achievements include progress in manned spaceflight, lunar exploration, developing the Baidu navigation system, and manned submersibles. In 2015, research and development expenditure of China surpassed $210 billion US, accounting for 2.1% of total GDP. The contribution rate of scientific and technological progress increased to 55.1%. Let's hear what the experts think of China's path toward becoming a leader in innovation. The Minister Wen Gang said, "An innovative country, in brief, is a country that takes technology innovation as its core drive in economic and social development." Another academician named Zhu Guanhua said, "I have a Chinese dream that in decades China will become the top in the world in innovation. This is a dream, but not an extravagant hope. I think our nation is capable of it. The key lies in reform. Supply-side reform is focused on innovation. According to Professor Chen Siwu with Yale University, the economy of China has little room for growth with the original investment. Now we need to rely on innovation to provide new drive. And specifically, they outlined these areas: electronics and information technology, supercomputing, semiconductors, machine tools, robotics, textiles, mining and rare earth industry, material science and nanotechnology, chemicals, agriculture, fishing and aquaculture, biotechnology and genetics, pharmaceuticals and medical technology, environmental issues, power generation and transmission, transportation, railroad trains, motor vehicles, commercial aircraft, shipbuilding, entertainment industry, polar research, deep sea exploration, nuclear physics, space science, and military technology. So those are all the areas in which the party is focusing research in the existing 5-year plan. Among the engineering accomplishments of early China were matches, dry docks, the double-action piston pump, cast iron, the iron plow, the horse collar, the multi-tube seed drill, the wheelbarrow, the suspension bridge, the parachute, natural gas as fuel, the raised relief map, the propeller, the sluice gate, and the pound lock. In the Tang Dynasty, which was 1618 to 906 AD, and the Song Dynasty, AD 960 to 1279 in particular, these were great areas of innovation. Now, in the 7th century, book printing was developed in China, Korea, and Japan, using delicate hand-carved wooden blocks to print individual pages. The 9th century Diamond Sutra is the earliest known printed document. Movable type was also used in China for a time, but was abandoned because of the number of characters needed. It would not be until Johannes Gutenberg that the technique was reinvented in a suitable environment. In addition to gunpowder, the Chinese also developed improved delivery systems for the Byzantine weapon of Greek fire. Probably most of you, like me, are not familiar with that weapon. I had to do a little research on it. Essentially, we have combinations of pine rosin, naphtha, quicklime, calcium phosphate, sulfur, and nitrous, just different kinds of nitrites. They are put together in a particular combination that was a highly regarded state secret in Byzantium, and as a consequence, nobody's ever really been able to recreate what they had at that time. In fact, when the Bulgarians first captured a whole bunch of this stuff and the weaponry and the machinery to use it, they were unable to do so. At any rate, Meng Huo and Pen Hu-Kui first used this Greek fire in China around 900 AD. Now, Chinese illustrations were more realistic than in Byzantine manuscripts, and detailed accounts from 1044 recommending its use on city walls and ramparts show the brass container as fitted with a horizontal pump and a nozzle of small diameter. The records of a battle on the Yangtze River near Nanjing in AD 975 offered insight into the dangers of the weapon, as a change of wind direction blew the fire back onto the Song forces. Well, at any rate, in July 15th, 2016, speaking about China's scientific revolution, there were last year some important comments. The Chinese economy has undergone radical transformation in recent years and is now laying the groundwork for impressive advances in science and technology. In particular, China is setting itself up to be a major player in the fight against disease, and there are many reasons to believe that the country will play a central role in the life sciences research of the future. For starters, according to a report in the McKinsey Quarterly, China spent more than $200 billion on research annually, a level investment that is second only to the United States. Chinese President Xi Jinping has positioned science-based innovation near the top of the national agenda, with the government's 13th five-year plan prioritizing complex projects in the emerging fields like brain research, gene science, big data, and medical robotics. China is devoting so much to medical research in part because the country has significant unmet medical needs. Now, by 2050, the Chinese population over the age of 65 is expected to increase by about 190 million people. Meanwhile, chronic illnesses now account for more than 80% of China's disease burden. So it is no surprise that China is already the world's second largest pharmaceutical market, or that its innovation expenditure, according to the McKinsey Quarterly Report, is expected to reach $1 trillion by 2020. Another reason to expect a Chinese research revolution is that China now graduates more university students in the fields of science, technology, engineering, and mathematics than any other country. About 2.5 million students per year, or about 5 times more than the United States. In science and engineering alone, China generates nearly 30,000 PhDs annually. At the same time, government incentives are luring Chinese scientists who have been working abroad, many with top-tier Western institutions, back home. From its inception in 2008 through mid-2014, this 1,000 Talents program has attracted more than 4,000 returnees. These trends clearly indicate that China has a real opportunity to become a major force in global pharmaceuticals research, and that there will soon come a time when breakthrough innovation occurs in China on a regular basis. Global pharmaceutical companies have taken notice. My own company has been working in research and development for 10 years. Back in 2006, we opened the first integrated R&D facility in the country, and the largest among international firms, and we recently opened a new R&D center in Shanghai's Zhangjiang High-Tech Park. In Shanghai, premier scientists, many having returned to China from major research centers like Harvard Medical School and MIT, will focus on diseases that are endemic to the Chinese population. These include lung, liver, and gastric cancers, as well as other liver diseases such as chronic hepatitis B, liver fibrosis, and cirrhosis. These diseases disproportionately affect people in China. For example, the incidence of hepatitis B in China is nearly 30 times higher than in the United States. Stomach and liver cancer rates are 11 to 18 times higher than in the U.S. or Europe. Thanks to advances in recent years, scientists can now identify epigenetic modification enzymes that regulate gene activities. This area of research is especially promising in the search for effective new oncological therapies. And by better understanding how these diseases manifest in Chinese patients, the industry is honing targeted therapies that then can be introduced in other settings worldwide. China could very well set the global standard for using epigenetics to gain a better understanding of the underlying causes of disease. In China, Novartis scientists alone are already running 15 drug discovery projects at different stages, and this pace of development will only accelerate. I'm inspired by China's potential for making landmark scientific discoveries, the author said, and as the country becomes increasingly important to global R&D, its contributions will be a boon for the fight against disease, both in China and worldwide. Now, I listed, if you look at Xinhua, New China News Agency, which I use as a home page on my internet, you'll see almost daily new things, including today, new innovations being listed, and they're not even on here. But at any rate, I picked 16 Chinese modern engineering industrial accomplishments to mention to you. The XCME's massive 220-ton capacity AC drive electric haul truck used for large-scale mining. The world's largest mobile crane, XCMG Group 1,200-ton mobile crane. Thirdly, China's largest excavator, the Sany Group 200-ton class hydraulic excavator. Fourth, the world's largest coal-to-oil refinery, the Ordos Coal Liquefaction Demonstration Project. Fifth, the world's largest nitride rubber facility, which is the Lanzhou Petrochemical Company 50,000-ton rubber facility. Sixth, the king of blast furnaces, the Shagang Group's 5,860 cubic meter blast furnace. Seventh, the nation's largest container ship, Costco Oceania, 10,200 ton container ship. The king of rolling mills, Anshan Iron and Steel Group's 5,500 millimeter heavy plate rolling mill. Ninth, the world's largest hydro turbine, which is installed at Three Gorges, a 70,000 kilowatt hydro turbine. The 10th, the world's largest horizontal lathe, the Wuhan Heavy Duty Machine Tool Group's DL250 5-meter heavy-duty horizontal boring lathe. 11th, the world's largest vertical press, Northern Heavy Industry Group Company's 36,000-ton ferrous metal vertical press. 12th, the world's largest bridge crane, the DHLD CW Group Company 20,000-ton capacity bridge crane. 13, the world's longest public bus, the PRT High Capacity High Speed Public Transportation System. 14, the vehicle with the most tires in the world. 15, world's largest Ferris wheel, the Beijing Great Wheel, height 208 meters, weighing 8,000 tons. And finally, number 16, the world's largest LED screen. Now, the point to all of this discussion of internal investment is that last time we concentrated on reinvesting overproduction in other countries that are somewhere between China and Europe, that is throughout Asia and Africa, as a way of diverting surplus production. In capitalist countries, when you have surplus production, workers are sent to the street, which is the reason why we have so much unemployment. Probably 30% of the United States is unemployed or underemployed, despite the phony figures that the government continues to release. And this is typical, and has always been typical, of capitalist countries. The only thing that got the United States out of the Great Depression that started in 1929 was World War II, when all of a sudden you had massive government investment in war production. Well, war production doesn't produce that kind of employment anymore, so we have a country with increasingly large numbers of people that can't find jobs or can't find jobs that pay enough. At any rate, the Chinese, as we discussed in the last lecture, have dealt with the problem of overproduction that they have with 1.3 billion people, all those of employable age, working constantly, and the Belt and Road programs, the old Belt Road, the old Silk Road that goes on land, and the maritime Silk Road that goes by sea, as one important way in which to divert surplus value. And today what we've taken a look at is the massive amount of surplus value that is being invested internally in China. The last time, of course, we talked also about, or in the lectures on the last 4 administrations, we talked about such great projects as the Three Gorges Dam. And of course those are big. But all of that together, and even with the Belt and Road programs, is not enough to absorb the enormous amount of surplus value being produced on a daily basis. So the party's program has been to do what has always driven capitalism, and that is to reinvent the means of production and the mode of production. But instead of sending workers to the streets when factories are modernized, what happens in China is, with all of this modernization, workers are sent to new jobs. And so that's an important factor for you to keep in mind. You want to go back over and read the chapter on capitalism to see how critical innovation has been in the history of capitalism itself. So with these comments, I'm going to stop this particular lecture, and we'll get on to others as time proceeds. I want to remind you again that the ABCs of Communism, Bolshevism 2017 is now available in Kindle books in 2 volumes. each of which is rather large, and the whole thing has been completely rewritten. One of the things I did was to eliminate all of the what was necessary highlighting when this was a handbook is one thing, but now that this is a 2-volume textbook series, what I've done is to get rid of highlighting except for the most critical dates. And I think you'll see that is when you pick up these new copies. So at any rate, that's enough for today.